Our project is the redesign and analysis of a waffle maker, and our group members are Lillian, Aiden, Lauren, Shaylee, Charles, and Adeline.
Now to introduce the waffle maker. A little bit of background about a waffle maker. A waffle maker is a popular kitchen device used for cooking the fun breakfast food, waffles. Our primary customers are restaurants and hotels, which are concerned about the final quality of the waffle and want even batter spread and the best waffle possible. Our secondary customers are families and small cafes who just want a fun twist on breakfast and need a reliable and easy to clean appliance for occasional use. We're anticipating 85,000 units per year to be produced based off of the current market valuation and different major waffle manufacturers providing services.
Here you can see an exploded view of our waffle maker with a numbered list of each of the components to the side.
Now we'll take a look at the product analysis. So here you can see the fast diagram of the waffle maker. The main task function is to make waffles, and then we have the basic function are to eject and cook waffles. The sub-function we have for ejecting waffles are to be able to access the waffle, and the sub-functions for cooking waffles are to contain the batter and add heat. We also included the primary supporting functions of assured dependability, assured convenience, enhanced product, and pleased senses. Here you can see the first of the two possible assembly sequences. As shown in the fishbone diagram to the left, we start with just the stand tubes and then add on the handle connector, pipe connector, and middle connecting bracket. Then we add on the waffle grid subassembly, which includes the covers, brackets, heaters, and handles. Finally, we add the housing and switch to complete the assembled waffle maker. For the second assembly sequence, we start with the waffle grids and then add on the heaters, covers, and handles. Next, we add the stand tube subassembly with its connectors and brackets, and finally, we add the housing to finish the assembly.
Based on the two assembly sequences, we performed an analysis to determine which one is easier for assembly. The main difference between sequence 1 and sequence 2 is which part is assembled first, the stand or the waffle cook surface. Sequence 1 was graded higher since the stand provides a more stable and easy base to build off of when compared to the cook surface, which would constantly have to be manipulated to be assembled. In order to aid our analysis of how to best optimize the waffle maker, we made a component mapping matrix. It can be noted that several parts accomplish the localized heat function and multiple parts are responsible for flipping the cook surface. Moreover, the secondary customers do not care about the flip cook surface function as they want a more reliable and easy to clean product. Thus, this presents a large opportunity to optimize.
This is our bill of materials. We use the CAD model, custompart.net, and tables for the manual handling and insertion times to make the time and cost estimations. The total cost estimate for the waffle maker was about $235. Waffle makers in the market range from $200 to $2,000. When compared to the lower end of this range, the manufacturing cost is higher than the market value. This discrepancy could stem from the estimations and assumptions made when calculating the bill of materials cost.
This is our quad chart where we classified the waffle maker subparts based on functional importance and manufacturing cost. Through this chart, we can see that components with a high cost include the top brackets, grid cover, heater, grids, handle, connecting bracket, and housing. This helped us to figure out where improvements could be made, such as combining or eliminating certain parts to be the most beneficial in reducing our manufacturing costs.
Next, we'll go into our product family design portion. First, we made a functional differentiation table. On the left, we see things that are the same for both the primary and the secondary customer groups. And on the right, we highlight the difference between the primary and secondary customer groups, which in our case was the flip cook surface, or moreover, the rotational feature. Next, we go into our component commonality table. On the left, we have the platforms, which are the main items of our waffle maker that cannot necessarily be changed. And on the right, we have our more module parts that we are specifically modifying or combining to increase that cost efficiency of our waffle maker.
So here you can see the full new CAD of the second version for our secondary customer group that does not have the rotational feature. This was reduced by 6 components And due to that change, there were 8 fasteners that were reduced as well. Here you can see the variance between the old and the new. On the top is the old versions and on the bottom is the new. On the left is the handle modification. We went from 2 handles to 1 because if you're not flipping it, you only need 1 to open it. Then you can see the inner brackets. We went from 2 to 1. And then the top bracket that has the notch for sitting within the inner bracket, that's been removed in this new version. Here you can see the product family design assembly sequences for the primary customer group and the secondary customer group. Thank you for watching.